All right, hi Geometry 10. Just wanted to drop a real quick video to maybe help you guys get started with your thoughts on the Spiky Door project. If you've taken a look at Friday's assignment, this is going to be something you guys are going to be able to be creative with and do some work on your own. Um, it's going to be a project where you're going to have to use some math ahead of your design, right? You have to kind of think through what this thing is going to look like before you start in on it. And I'm hopeful to give you some guidance on that on this video. Um, this is something that's going to be done over a period of time in that this project is going to require you to figure surface area and volume. And if you've looked ahead in Mod 10 at all, or before we left school, um, surface area is the first part of Mod 10, and then volume was the second half. So we'll work through the first part, and I'll have you submit what you have just as far as surface area. And then the completed project later on when we wrap up Mod 10. So probably looking somewhere in the range of the end of week 3. And if you were on connected at all today, you have heard that our time out of school has been extended, which means our e-learning time is going to be extended. So week 3 will be, only part of what we're going to do from a distance. So let's take a look at what's being asked of you first. So the Spiky Door project. So you're going to create with pencil and paper your plans for this design. You're going to calculate surface area and volume of your object, and then build and decorate this object as well. And assuming that we get a chance to get back together in class this year, we're going to have you bring your spikes in, and then we'll actually put these on the door of Pink 102. So this is a pyramid. If you've been taking a look at some of the assignments this week, we talked about prisms and cylinders first, and then pyramids and cones second. So this is going to be a pyramid. It's going to have a base, and then the faces will meet at a point. So the easy way to do this is to make this a square base. But if you're looking to try to pick up some extra points, it's going to be more challenging, but it'll offer you a 5% bonus on your score if you select a base that is a regular polygon of more than 4 sides. So pentagon, hexagon, octagon. Obviously, that's going to involve you calculating some area of a regular polygon for your base. If you're willing to take that on, go for it. I'm going to reward you. So your first object is to select a shape for your base. And I'm going to walk you through a couple things here. Let's say that you're feeling like this is something that should be done as a square. Awesome. So in your house, if you've got a ruler, or if you can get a hold of a ruler, if you've got a little brother or sister, they probably brought theirs home in their backpack, ask to borrow nicely. And we're going to do this in centimeters. Okay. So you want your base to be between 150 and 200 square centimeters. Well, if this is a square, both sides are the same. So what are your perfect squares that are between 150 and 200? 12 times 12 is 144, so a 12 centimeter square is actually too small. You need this to be somewhere between 12 and a half to 14, right? Because 13 times 13 is 169. 14 times 14 is going to be 196. If you go 15 times 15, that's 225. That's too large. And then eventually your object is going to need to have a volume of between 750 and 2,000 cubic centimeters. So if you have 200 cubic centimeters for your base, that's a 10 centimeter height, which is about 4 inches, right? If you go, let's say 200 and you're trying to get to 750, that's about a 3.5 centimeter height, which is a little under an inch and a half. So that one's not very tall, right? So you want to kind of think through how that goes. So let's start with the idea of a square first. So if you're going to go, let's say a 13 centimeter square, right? That's going to start with a line. And then how do I guarantee that this line is square? Well, if you've got your ruler, the edge of that should be square-ish. And you can go ahead and start what would be the sides of your square and feel fairly confident that you're at a 90-degree angle. Is it going to be perfect? No, unless you go ahead and get maybe a protractor. So I'm kind of eyeballing these, right? All right, so clearly Mine is not a perfect square, a little bit wide, but it'll do. So if this is my base, so our pyramid is going to come off of this as triangles, right? So we already know about the slant height. That's the height of this flat triangle. When we fold this up, the three sides are going to meet. The distance from your base perpendicular to your point, that's the height that you're talking about when you start considering volume. So before we start drawing a triangle here, we need to think about what slant height is going to give me the height that I want. So if this is 13 by 13, 169, and I need that to be somewhere between 750 and 2000, let's just pick 1000 as an in-between, right? So if you took 1000 cubic centimeters divided by 169, that would tell you what your height should be. Now you're starting to think about, okay, here's my slant height. This is the height that I'm interested in. And then this is the distance from my center point, apothem, right? So you're going to have to do a little calculation to figure out what this slant height should be. And you're going to have to find a way to find where the center point of your square is. Okay? So the second piece here is you're asked to complete a full-size drawing of the net of your object. So if you remember back to 10.1, the net is what happens when we take a three-dimensional object and flatten it out. So if you can imagine taking a box and cutting down the edges where the sides meet and then flattening it out, well, that's a net. So for instance, if we're thinking about this square, and if this was 13, so 6.5 is my center point there. And again, I'm just kind of eyeballing this. So that's roughly where the altitude is going to live. How high do I want that to be? And will you do your math on that? It may look something like that. And if this is a square, you'll need 4 of those. So you can see that you may need a slightly larger piece of paper to do this work on, or 2 pieces of paper side by side. Right? You maybe tape 2 together. So on your drawing, you're going to go ahead and label all your dimensions. So if this is 13 centimeters and this is 7.5 centimeters, and then somewhere on here, you're going to calculate the surface area of your object. Right? So you're going to go ahead and use your formulas that you would use to find the area of the base and then the area of all your lateral faces, right? The lateral area. Let's go a little bit farther down the procedure. So you're going to show your formulas and all your calculations somewhere here on your paper, and this can't just be haphazard. Don't just throw numbers here on the side and expect me to do all the work. Part of the main part of your grade here is the math that you're doing, less so the drawing. So how clear is your work? How accurate is your work? How organized is your work? That's going to be a big part of what your grade is going to be. So I want to go ahead and flip one thing over. Let's say you're feeling a little bit adventurous and you're saying to yourself, you know, I really would like to pick up some extra points here. And I would like to do a base that's something other than a square. Okay, so how are we going to pull that off? Well, if you're going to do a regular polygon, keep in mind that a regular polygon, if you inscribe it within a circle, all its vertices will touch the circle. So if you happen to have, let's say, a compass at home, you can use that to create a circle. Another option, it's maybe a good option, is go into your pantry and maybe you've got a tub of disinfecting wipes that you just picked up at the store this week, or maybe a coffee can or something else that you know for sure is round. And you use that to draw your circle. Now I kind of, again, just eyeballed this, right? So if we want this to be a hexagon, I need to find where the diameter of this circle is. pretty sure I missed it there. And there. And there. So this one's probably a little bit lower, maybe about here. But these would be the vertices of my hexagon. All right. So obviously you would put your construction lines in a little bit lighter, and this one, not too bad, right? Not too bad. So if we can identify wherever we think our center point is, and now start to take some measurements. Remember, we need the area of this, so we need to know what is the length of the apothem, right? About 4.8 centimeters. What is my radius? It's about 5.5 centimeters. So you'll measure that out, right? And now remember that I've got triangles that are living off of the sides of this hexagon. So I'm going to go ahead and calculate, what is the distance of my slant height, and what is that going to result in my height for my volume, right? So this is some of the basics about how you're going to set up your object, your base for your drawing. Right, from there, you can go ahead and work on through the math. Obviously, we'll still continue to do our live conferences. So if you have questions on this, feel free to ask questions at that time. So again, just a reminder, the volume formula is going to come later in the module. And so the calculations for the volume, you can wait until after we've covered that in class. This particular project, when I used to deal with my classes in school, we would take some time in class for the construction part. Some of you guys are very creative, and some of you that's not your thing, which is fine. Some of you guys keep creative tools at home, and some of you don't. So I don't want to presume that everyone has the same access to materials. So the actual grade for this project is simply the drawing and the calculating. But if you are that type of person that wants to go ahead and build this, please do that. Note that right on my paper, I say, I don't want you to feel like you need to make a trip outside your house to complete this project. But if you have things on hand in the house and you can use them, feel free. And I would love for you guys to be able to share out images of your work. And eventually when we get back into school together, we'll display them on our door. And you can see that these are not fantastically perfect, but they're all pretty creative, and they're you can decorate the sides in any way that you'd like. So that, I hope, will get you started, give you some of the basics, walk you through some of the things that are on the paper that you might not have maybe felt like you had a real good understanding on. And then once you've started on this and you have some questions, be sure to bring those to me during conference time. Just one more time, a reminder again, is that there's no new assignments coming your way during spring break. You're not expected to do schoolwork during spring break. The actual assignments here in week 1, the due date on them is March 30th, which is the Monday that we will return back to school from the spring break. So you've got a little time to put this piece of the project together. And then during week 2, that first week that spans March 30th to April 3rd, there'll be some more work time for this project.